So I would like to start with a question here. How many of you consider yourself a front-end engineer or front-end developer or any of that? I think maybe 60, 70%. To the rest of you, I ask, why are you doing it? I couldn't be any more clear in my title. But I understand you. I don't consider myself a front-end developer myself, even though at some point, I think in like a trade magazine in Norway, there was this headline, Mikael or Michael when I'm feeling cool, Michael loves JavaScript. That's the entire headline. There was a discussion on discussion.no after a fact about if I, in fact, was wrong to do so. But still, so I don't personally consider myself a front-end developer, but I think many in my circuit does. And I think also there might be a sign that I am a front-end developer because I've been doing front-end development for a long time, and for all that time, I've felt some sort of like, I can only describe it as inferiority complex for backend developers. I think when I'm starting out doing development 15 years ago, 20 years ago, I always heard this notion that front-end development wasn't real programming. It was HTML, CSS, JavaScript, and it wasn't proper programming because it was markup language. So it was notion that markup language wasn't real programming, so it wasn't programming in fact. So imagine my surprise now, 20 years later, 2025, those same proper programmers are the ones also sitting there surrounded by YAML files and saying they're doing the proper programming. But now suddenly the markup language is proper programming. And they've tried to circumvent it in some way and calling YAML, which was originally called yet another markup language. They just transitioned from that a year after, saying YAML ain't a markup language, but if it markups as a duck, it's probably a goose. So I can see that. I can see through them. But I think it's odd that for some reason, I think DevOps has mostly been something that backend and platform engineers talk about. I really hear it by front-end developers as something to consider, something to be excessively into. So I think most hardened backend developers or infrastructure people talk about metrics, infrastructure as code, CI/CD pipelines. But of course, that's not the entire picture of it. And it's definitely not just for the backend people out there. And I don't think I'm alone when thinking that this is something for the backend people. If we're seeing surveys such as Accelerate's State of DevOps and Stack Overflow's yearly surveys and other surveys as well, is an overly representation of backend people saying they consider themselves as DevOps specialists, they consider themselves interested in DevOps. By a large margin, this is just made up like graphs, but the notion is real. And seeing those surveys, about 2 to 3 times more representation of backend people than front-end people in DevOps types of surveys. You can argue that it's also because maybe there is more backend people out there and less people consider themselves front-end developers. But I could also argue it's just statistics that I've found to confirm my already established fact for myself. And I've been thinking about why this is the reason why does so few, according to me, front-end engineers, front-end developers talk about DevOps as a concept. And I think it kind of makes sense if we're looking back at the history of how the front-end development field got evolved. This is the ideal for a long time, and for many still is, the ability to just create an HTML file, just refer to a simple script file for some added interaction. And there's no infrastructure, no building, no tooling. It's just HTML, HTTP, standards, a good old browser that's interpreting what you're doing. And as I said, this is still considered for many the ideal to do front-end development. But at some point, we started moving a lot more logic, business logic, and view logic, and complex calculations, and we moved a lot more code over to the browser and did the execution on the browser as well. So we had some sort of need for tooling. But this was the first tool, at least that I can recollect, that we're doing, to just concatenated all files to one single file. We can uglify or mangle the file, and then minimize the amounts transferred to the browser. So this was a tooling, but it's still minimal type of tool and just introduced by necessity. To deploy this, again, it was essentially just copying files, right? We used FTP servers or clients to just have a remote place with a static host that can serve static files. We can just drag and drop and copy files over. That's the deployment. Only missing piece, we didn't need any advanced infrastructure. You could just find somewhere that has static hosting, and you can upload the files, and you're golden for days. So with this, we could create simply real value-bringing, good interactive applications with a few files, just upload and have them working. At some point, and at this point also, front-end was just front-end. It was simple. It was a uniform a term. It was HTML, CSS, JavaScript for some dynamic interactions. And it was simple in a way. And as it was simple, the ecosystem and the tooling could be equally as simple. So the process I'm describing now is kind of both the history, but also the current practice in transferable terms for front-end aspects. But I think it doesn't make sense now to talk about front-end as front-end, because front-end is the simple cases, but it's also a lot more advanced cases. So we can't talk about front-end as a uniform term that it has some concise meaning to it. Front-end in one team and in one organization can be in an entirely different thing than front-end in an entirely different team. So we don't have a concise description of what front-end is. And I think this type of fragmentation of the field as a whole and the history we have with no tooling and the ideal of no tooling has become and has grew into this feeling that we don't need to think about things like DevOps. DevOps isn't for us. It's for the ones that grew up with the need for advanced tooling because they had microservices, so they had needed to do advanced rollout mechanisms. So they have an entirely different story, an entirely different evolvement of their environments, which made them more susceptible to the concepts of DevOps. But yeah, we had different types of front ends, and in some cases, it means like a simple blog that's never been updated and has only draft modes. That's mostly static and more static than it would like. This is front-end type of thing. But on the other hand, we have advanced applications that are distributed in the same exact manner, using the same technologies, but is highly advanced and highly dynamic, and is proper application software development at its finest in the same type of thing. You can argue that both type of these are front-end, but it's definitely not the same type of front-end, and they have different requirements in how to manage them. But I think that both these aspects of front-end development is also has the requirement for thinking DevOps, and there is no reason we shouldn't do that, because in essence, DevOps is much more than tooling and infrastructure. That's often the things that developers talk about, like how to do their latest Kubernetes cluster in monitoring complex clusters, or how to roll out things in an easy manner. These are things that often occupy our conversations, but DevOps is much more than that. And I think DevOps, in essence, I like to think of it as essentially just avoiding a bad production. Avoiding a user standing outside in the rain, calling you because something isn't working. I've had this exact literal scenario happen. Someone was standing in the rain, calling me on their phone, saying, "Hey, you know the app you made? I didn't make the app, but I was part of the team made the app. Yeah, it doesn't work. I can't buy bus tickets, so I can't get out of there." He was standing in the literal rain, complaining to me about something not working, and that's embarrassing. And it should be avoidable as well. The overall goal, I think, is having like sunshine in production. The cloud should be good, not without the rain and the bad forecasts. And again, we as people that work with front-end systems, we serve an important task here because we're doing user-critical, business-critical, value-critical solutions in production that affects thousands of people, and they should work and they affect the everyday life of people out there. So to ensure the sunshine, we don't only need to be meteorologists, but you have to be skybenders controlling the weather as well. And I think that's important to remember. So front-end is complex. It's user-facing, it's production-critical, and we need to take ownership of these processes, and I think DevOps is a part of the framework that allows us to do that. So DevOps is very much relevant for us, and relevant for front-end development. And I think, and DevOps matter. It's, there are statistics, again, confirmation bias is good, but there are statistics that you can cherry pick and see that teams that succeed in highly succeeding with DevOps will fix failed deploys 2,000 times faster. It looks like a typo, but it's not a typo. So often in like productivity research, first of all, you have to take it with a grain of salt because it's a lot of subjective and self-reporting based, but it's still kind of like an indication. And 2,000 times reported able to fix things 2,000 times faster. Also, reduce failed rollouts with 68%. Are 2 times as more likely to report higher customer satisfaction. And they can ship features 106 times faster. And yeah, in DevOps research, again, they often separate between low-performing teams and high-performing teams. So these are numbers that are considered from high-performant, well-defined teams that work in a DevOps manner and succeed by doing so. So it doesn't mean like use a couple of DevOps principles and you will achieve this, but if you're succeeding and if you're building a DevOps environment, this is some numbers someone has reported. And I think, again, it's important to think it's not about tooling, it's not about the infrastructure, but I like to divide it into 3 parts. So operational and production responsibility, philosophy and culture, and methodology. So the overall goal here is to cover these parts and see how it affects and how it relates to us as front-end developers. Meaning it's less like this, people sitting there being surrounded by YAML files, and is more like this, which is teams coming together, improving the way they work to achieve a common goal. DevOps is a team effort, and it requires ownership from everyone, I think. So again, definitely DevOps is not a backend thing. I think it's often confused with a backend thing, at least maybe I'm projecting, but it's definitely a software thing. So the operational and operational responsibility. And I think it's important to like establish the fact that as developers and as coders, whatever, coding is merely the tool to achieve something. Just as building infrastructure and roads is just a tool. We don't need actual roads. We need to get from A to B, in a sense. And the same is coding in a vacuum achieves nothing. So our jobs is to try to achieve an effect with some end user or business at the side. That's like, and we're using code as a tool to achieve that. And I think it's also important to think of it as you have to be able to observe the wanted effect on the other side of this. And this has to be continuous, because much like raising kids, something that's working one day doesn't work the next day or even the next minute. So you have to be able to adapt. So to maintain the sunshine I'm going on about, we have to understand that this isn't just within our control, but it is also within our responsibility. And that's what I think of as operational responsibility. And again, it's easy to say it's the team's responsibility, or it's someone on the team's responsibility, but I think it's a team effort. So it's not someone's responsibility, it's your responsibility. But luckily, again, it's the plural type of you, so you're part of it, but you're not alone. So making it a team effort, it requires cultural improvements, because just saying something, just trying to achieve something and just preaching something isn't the same as actually living it. So to be able, I think, to achieve the real gains of this, you have to build in as a response to the cultural DNA of a team and an organization. Because when things go wrong, when we waver, when we doubt, the fallback mechanisms will be what we've built as a culture within our team. So if we're trying to fix production critical things in a quickly manner, we can't fall back and regress to improper ways of handling it. We have to have ingrained the way of thinking as a DevOps principle, as a team, and that requires culture. Because yeah, things will go wrong and we have to fix it. What's our immediate response to that? That's the culture as well. And philosophically, I think DevOps is all about flow-based development and flow in your work. And we'll see how in a minute. But again, ensuring that flow will require the entire team and organizational culture to succeed. And if we are to succeed with this, it requires to change and adjust the way we work continuously. Alignment of the way we work, this established fact as we as a team or we as an organization work, is often called methodology. And it's also, I think, an important part of team culture, because team members get swapped out. We need a new form of onboarding new team members within that culture to also fit within the way we're working, and methodology and processes and frameworks are a good way to do that. To ensure like a structural capital of how we should work, this is the established practice. And again, according to a Spacelift survey, 49% of organizations said that DevOps is their most popular process framework. And 61% again of organizations say that DevOps as a method has improved their deliverables. So if you want to ensure everlasting sunshine in our services, we need to detect when there are problems and be able to quickly fix them. And again, it's not if, but when there are problems. There will always be problems. And problems can be either bugs, or it could be misunderstood requirements. It could be that we didn't understand the circumcisions that something is meant to operate in. There could be a lot of different things that cause the wanted effect to not be reflected in our observations. So we need to detect what the problem is, and that's as quickly as possible. And when we detect what the problem is, we need to know how to improve it as quickly as possible. We need to be able to roll out a fix as quickly as possible. And hopefully, as a bonus, we should be able to prevent similar cases from happening again. And this is what I think of as flow-based development. So we roll out changes to a system, and then system here I think is a broad term, like an organization. It can be an IT system or a solution. It could be a website. It could be an application, whatever. But we need to observe the effects and the wanted effects back again. Again, you probably heard about this called as closing the feedback loop. But it's also like closing the feedback loop of verification of understood requirements, and if it has the wanted effect, and if the quality of what we're making is in line with what the customers and the businesses are expecting. And we want to minimize the time from some requirement are either identified or being well known. And we want to minimize the time from it occurs to it's realized. So we want a safe and continuous development of our services. And in DevOps, a subpart, like a small part of this, is often referred to as cycle time. And again, this is something that we tend to talk about from a tooling perspective, but it's also cultural and philosophical in a way. But essentially, the cycle time is the time it takes from we start on a new requirement to it's able to be observed in production. And if we want to ensure continuous flow, we should minimize that time. And there are several ways to improve that time. We could tackle the tooling part of it, minimize the time it takes to actually package and ready make some sort of solution and ship it into production. We can make it as easy as possible to understand the requirement or to debug issue. We can reduce the scope of each task to minimize them, so I'm using small changes. We can also make sure that we never have to deploy at all. For instance, make changes that's already there, doesn't require deployment at all. And we can also ensure that there's nothing blocking us from doing releases, but that's often a problem as well. So let's talk about the first part, improving build times. I won't go into much detail on CI, continuous integration, continuous delivery type of aspects here. But I think it's important to note that this isn't something that you as a front-end developer, a front-end engineer can outsource to like the infra team or just use a ready-made workflow in GitHub Actions and call it a day. I think it's important to have some sort of ownership on how your solutions are deployed and how it's packaged and how it's built. As you need to see, where is it possible to leverage caching? Where is it possible to do parallel flows? Where is it possible to think critical paths of building your application? What do we need to actually get this observed in a production environment? And this is something only people making the solutions can know for a fact. And at some point, I'm using apps as an example today, mostly because it's harder to do DevOps in app-related development. And so it's easier to use that as an example where I'm failing, so I don't have to realize I fail at every aspect of it. But it's harder to do continuous development in apps, and it's harder to fix things that has gone wrong because a lot of apps are still actively used by users, and we have no mechanisms of forcing an update. So the principles apply, but I think it's easier to see the negative effects of not having proper working DevOps mindsets in app releases. So, and this is absolutely true when it comes to build time, because build times on apps is horrendous. So trying to build an app like a QA released on when we're merging to main in the app world, at some point it took our 5 hours to build. So every time you push to main, it took 5 hours because you have to build on iOS devices, and the iOS runners on GitHub Actions is slow without having your own Mac Mini running and some sort of dusty office. But it took 5 hours, meaning that just to get a QA release to verify if this actually works on different devices, it took 5 hours. And think of the implication of this. It means that every time you add something, it queues for that 5 hours. So essentially, it couldn't take days before you can verify a small change in the app. And there's no coming around it. If you're building an app, it took that time it took, because it was slow runners, and building in Xcode tools is slow. But we also saw that this being a React Native app, it's 99% of the changes we made was actually in the JavaScript bundle thing, which doesn't require the entire Xcode build tools. So just by redesigning the build steps, we can cache out the so-called IPAs from iOS builds and just swap out the specific bundle inside of that, and we could reduce the build times to 5 minutes. So in 99% of the cases, the build time reduced from 5 hours to 5 minutes, just because we knew the type of changes we made, we knew the type of things we could do to improve it. So that's important, that we as developers that own the system also own the workflows. So the simplest or most effective way of reducing cycle time is to simply just reduce development time. That's the largest part of the cycle time, is the amount we're using to actually produce and understand requirements. And it's easy to say, just work harder, but that's obviously not the solution. But we could work smaller. So instead of trying to solve a lot of things that takes a lot of time, we could divide that into smaller parts and ensure the flow-based development that we're talking about. So making small changes like this is key for always being in so-called deployable state. So if you're reducing the amounts you're trying to achieve at once, you can increase the flow, reduce the cycle time, and also have your code base in a clean deployable state at once. And this is hard. And I rarely like being dogmatic, but I try in my team to say that PRs should rarely last a day. Again, this is hard to do, and it is not a catch-all rule, but it's something to strive for. Because what happens when larger changes? They are blocking our release, because we have there's some large change that just grows and grows, and that blocks and depends on some other change that is also out there. So bigger packages, bigger changes also blocks rollout from other changes. Again, I call this the simplest way to reduce cycle time, but it's not easy and requires the entire team to do this. It is hard work. It's part technically hard. It's part like culturally and process standpoint, it's hard as well. It requires us to think about sizes and split sizes and doing work on task level instead of just thinking that we can sit down and produce. We have to split things into manageable chunks. And this isn't something just one person can do in a team. We can just say, oh, she's the team lead or she's the tech lead. She'll handle that. We'll just manage the tasks that are in the backlog and go for it. And I think that a lot of developers, myself included, is happy to talk about how do we improve development experience? How do we do DevX? How can we use tooling to improve our flow? But it's really, I never hear about like developers saying, how can we improve our board experience? How can we ensure that we are able to do flow-based development in the perfect manner and have uniform tasks that can be measured with cycle time? It's not one person's job, but the entire team's job. And this, I think, is a requirement for doing a flow-based development. If it's hard to remember, I've come up with a catchphrase, which is because continuous delivery takes hard work across the board. So, pretty happy. So when you have smaller tasks, you will avoid blockages, but also will increase the frequency, and you will be able to generate value for customers and businesses in a higher pace. But it's also easier to go around and circumvent the specific changes often. We'll see how you can do this in a moment. But with smaller changes, it allows us to be more confident at deploying. Because this is a real thing, deployment fear. So there's a negative spiral, a snowball effect, because when you have larger changes causing higher risk, and you get a fear of deployment, then you won't deploy, then you're stacking up all the changes, and there are more changes you aren't able to deploy, because last time we deployed, it was a shit show. So now we have to be entirely sure that this works perfectly. But of course, the solution isn't to be more sure about the deploy, it's just to deploy more frequently, because that's less changes, means less things can go wrong. And this is a hard thing to communicate, I think, because the gut reaction for especially like non-technical people is to say that, but we have to be sure that this works. And that's true, but we can make sure it works or reduce the consequences of if it doesn't work. And I had this a few weeks ago. I got a question from a non-technical product owner at the customers saying that, but why did it deploy at 3 p.m.? And I guess he was being rhetorical because obviously it's a risk deploying and then leaving from work. But I tried to answer him sincerely in either case, and I said, the problem isn't necessarily that they deployed at 3 p.m., but that they hadn't deployed previously, because they have had a lot of different things they had to solve, but they just changelog grew and grew until the day they couldn't wait any longer because there were a requirement to deploy a previous thing. And it was hard to cherry pick that specific change. So they had to do the entire change, and introduced a bug that was not related to the thing they had to release. But since it's hard, they were larger changes, harder to cherry pick, it caused an issue that didn't need to be an issue. And the immediate reaction from the non-technical aspects was, we shouldn't have deployed. But the reason or the actual way to fix this is to deploy earlier and deploy more often and deploy smaller. One way to achieve that and to have deployable state is to use feature toggling. This would allow us to roll out code in production that is void. It's there, but it's mute. It doesn't trigger any action. It shouldn't do any harm. Shouldn't do. But this can allow us to split changes more granularly and to think about continuous deployment in a different way. In front-end development, there are many different ways to do this. I like to use the open feature API, which is, since there are, even though feature toggling as a concept is very banal, it's just a small thing. Is this something we should activate or not? But there are many different implementations with different features, and it locks a powerful type of patterns to use. But as there are many different solutions, it's hard to switch out different ways of doing it. But Open Feature is a library that ensures a consistent API across the different types of implementations like Unleash, Flagsmith, and whatever. And you can pack that in and specify a type-safe way to handle flags. To use this, you would just check, is this flag active? If it is, use this new thing. If not, just void it. Of course, if anyone, last time I had this talk, someone came up to me afterwards, but the way you're using feature flag here will always ensure that next are using dynamic outputs. This is just an example. If you want to avoid dynamic pages in Next.js, you could just move this feature flag over to the middleware and have the same exact principle, but this is easier to show. You can also simplify this and just use environment variables. It is totally viable to use this. But what you're missing here is the full potential of feature toggles, because feature toggles can also allow us to do things like progressive rollouts, saying, I will roll out 5% every day for the next whatever days until a critical mass, and I'm sure that everything goes smoothly, and I'll roll out to everyone. I can also do canary releases saying, this group should get these new features. If it works, roll it out. If it doesn't, backtrack. And we can also do kill switches, like from a control panel, from a dashboard somewhere, we can just say, this doesn't work, kill it. So it's not just about toggles, but it's about controlling rollouts and controlling exposure of your APIs and reducing the blast radius if anything goes wrong. So even if we do continuous development, we do master the craft of having small changes, we do feature toggling, we have an amazing culture, we still have to see if anything goes wrong, because for me, and I guess from everyone in Norway, we're used to this, but it will rain. So we have to be able to see the first sign of bad weather. And we have to do, when bad weather occurs, we have to find what is causing this bad weather. What's the reason this happens? And not every problem can be easily reproduced locally. I'm sure every one of you had like some sort of issue that's just impossible to reproduce. So we have to be able to see what is causing the issue, where it's running, where it occurs, without being able to reproduce it. And this is hard work. It is easier said than done, because essentially front-end development is the most advanced distributed systems ever made. I think thousands of devices that we don't have any control over running your software, and that you have no control over seeing, could we scale up? No, they have terrible hardware. They have perfect hardware. They have the quickest hardware there is, so it changes some sort of race condition. Or they have poor network. They have good network. They have small screens, large screens. It's impossible to reproduce every permutation of devices there are. So we need some sort of way to not only reproduce things, but find out when an error occurs, what's the issue. And the distributed nature of front-end engineering, I think, makes this a lot more important. And this is often called observability in DevOps and software engineering maintenance terms. And it's a key factor of debugging production environments. The better observability you have, the easier you can act if something goes wrong. Again, it's easy to talk about, it's hard to do, and I constantly sin on this as well. It's always the type of, when an error occurs, you find, oh, we should have had better logging. If we only thought of logging this type of case. Or even you have that specific type of logging, but you don't know what occurred before. So you don't know what leading to this, because not every action there is a distinct action, making it like individual of what happened before and after. So state in the application, maybe we didn't have that, so we can't reproduce or whatever. So this is hard. And I think, again, maybe I'm projecting, but I think things like observability and logging and other types of observing the state of the application, I think this is something that's often easier to find in backend development code bases that they have in place. And I think I hear more backend developers talk about this. And I'm sure you have like problems today that you can't reproduce because, and they hurt. Especially, again, using app as an example because it's hard to roll out fixes, so you feel the pain more. But there are some versions of an app you have where we didn't do proper logging at specific points. So when people went onto the bus, they tried to show a barcode, and the wallet was visible. So it blocked the barcode, so we were able to validate your tickets. We had code that should, in 99% of the cases, prevent this. But for some reason, on a device level, it was blocked, like permissions to do this. And we couldn't find out how. We just heard it happened again there. Went a month, it happened again there. No way to reproduce it. So we needed to observe. And this, again, things like this hurt because you know it affects people and you're unable to fix it, and you can't find out what because you aren't able to reproduce. So you have to do proper observability. So we need to think carefully about logging, error handling, metrics, tracing, etc. And we'd like to separate things into two, and there are two main categories, but there are, of course, much more to this than those two categories. But the observability is the ability to find out what has gone wrong. And a sub-part of that is tracing, for instance, what has gone wrong at what specific service, for instance. And we have monitoring, which is trying to find out if something is wrong. An example of observability and tracing is a solution called Insight Hub, for instance, where you're able to leave breadcrumbs for every user interaction. So when error is logged, you will able to see like the user clicked that, this action happened, and you can try to see what led to this. So you can build some sort of state of the application in addition to just see that something has happened. And for tracing, this is a positive note. Lot more frameworks and engines like Bun and Dino and whatever has built-in support for things like OpenTelemetry. So it's accessible now. I think this is important because a lot of us are running both on the server side and on the client side, but a single action from a user, no matter if it's occurring on the server or on the client, is this type of the same action, so we need to tie them together. And we could use like correlation IDs, but it's tough to have consistent correlation IDs. So something like OpenTelemetry is not easy, I think, but it's still easier, and it's well worth the effort to do this. On the monitoring side of things, I think it's also a quick win for a lot of front-end projects running complex UIs, because we have the semi-standardized way of seeing different types of metrics and health states in front-end applications. Such as how long did it take before the first byte received, how long before a request responded at all, how long before I can interact and look at the information. These are things that is in Google's Web Core Vitals, and also what's used in things like Lighthouse. But you're able to use this, and this is logged on the client side of things. So you'll see what the client observes. So it's monitoring the distributed system of users. And if you're using Next, for instance, this is easily accessible. It's accessible for everyone in every way, but it requires a bit more like boilerplating. But in Next, this is very easy. You have a built-in hook that just using the send beacon API, which is specifically meant for analytics, and you just feed every this metric to a specific endpoint at every time, and it's down prioritized. So if it's poor network, it wouldn't interfere with your core services. This could then just collect all the Web Vitals metric to an external collector. And it could look like this, like the system diagram of it. So from the client, you can output the Web Vitals for monitoring. On your backend side of things, you can also output the OpenTelemetry hotel information through HTTP sync. collect that to a Prometheus monitoring tooling and as a collector, and use Grafana as a visualizing. And things like Web Core Vitals, they're ready-made dashboards to use in Grafana, so it's a quick win for many cases, I think. And I think things like Prometheus and Grafana is, again, I feel like it's not talked about by front-end developers as much. But I think it's critical that we take part of designing dashboard, designing queries, seeing what we should monitor, seeing what we should have alerts on, because we know the application and we can't outsource that. But what is even better than being able to act and detect issues fast? Preventing them in the first place. So detecting and reducing things as early as possible, we can avoid having these like reactionary fixes. So that will reduce the feedback loop in a way. So this is often called a left shift or a shift left approach, where we try to find out as much as possible on the left side of things in our feedback loop. And one way to do this is obviously by testing. And we often talk about like the testing pyramid, with the unit test like the fundament, we should have a lot. Unit tests, we should have some integration tests, and the holy grail of end-to-end tests that could catch all the solutions, all the issues we have. And honestly, it's in many cases is magical. So being able, there are a lot of different things we can test with testing the individual parts of it, because the interaction between different components is just as important as the specific components themselves. And using end-to-end tests, we can instruct an actual browser to navigate to a specific part and validate that it actually showed the value we actually wanted to show. And it, even better yet, you can send that to different browsers, so we can test across different headless browsers. And seeing that in Google, this works, in Chrome, in Firefox, in Safari, this works. And this is valuable because, for instance, Safari has a lot of bugs and traditionally, so being able to validate this is promising. But of course, the reality is, it's very rarely we need to critically verify that the title of a page is correct. More likely than not, it looks like this. It's a lot of state, different asynchronous requests. There's a maybe there's an authentication service that is depending on specific claims or scopes that has to be correct to be able to test this. And the reality of it is that you often use a lot of time to implement. It's green, it's working locally, you push it, and it's red. And you try to fix it, and it's fixed until it's not. And it's maybe fixed, and maybe not. So it breaks more often than it's actually working, and you can't trust the results of them. And even though if you get it to function kind of stably, it often, more often than not, when it fails, it's due to an actual fix you have done and forgotten that it's used. Because often, honestly, it doesn't bring as much value. But luckily, it's hard. It's really, really hard. And I've invested a lot of time in trying to make this work. And I promised in the abstract of this talk, I will show you how to actually make it work. And I've found the solution. The solution is the testing pyramid is a sham. It's outdated. It shouldn't be used. It emphasizes too much of the value of end-to-end tests. It emphasizes too much value on unit tests. And I think we have to redefine it to not call it the testing pyramid anymore, but the testing open sandwich. And I get it. It's not as catchy, but it's more modern. It's more correct. And I think it's healthier to focus on that. So focusing on integration tests, I think, brings almost the exact same value, but it reduces the flakiness and the time required to build them. And it kind of looks dissimilar. There are some things you can test, and there are some things that is harder to do, but still, this is more reliable, you get more value of it, it's easier to do, it's quicker to run on the CI, you have more ownership to it because it affects you and you can see the effect immediately. So it's a better return of investment. There are other ways to shorten the feedback loop on the CI/CD as well. Again, this is something we have to do as front-end developers. We have to take ownership of our CI/CD pipelines to be able to do this. So for instance, using Lighthouse to see the web core vitals change on each pull request or change locally, having like an indication of if what I'm doing now dramatically reduces the performance of web vitals, is important to have continuously as you develop. You can also do this on preview branches to check it. It's not important to read the code itself. It's just I'm trying to uncover like unknown unknowns, so you know that this is a thing that you could do and it serves this purpose. So doing this analysis on preview branches also is something that can catch a lot of regressions on performance-wise, which is hard to catch way down the road, but it's easy to fix if you're introducing them. So doing web vitals on preview branches, which again, this requires preview branches, which is in many architectures hard work now with Kubernetes doing like to spin up a temporary type of branch for preview branches. So if you have the possibility, I would highly recommend using preview branches and trying to make some effort to make that possible. And this is not long ago, just before Christmas, I was helping releasing a website. And just before releasing, I found that for some reason, I didn't know the code base, but I was opening up, checking the performance, and checking, this is really, really slow. And I found that the bundle size was 11 megabytes for some reason, which wasn't required at all, because it was mostly static site, so something odd was going on. And this is something that could be easily detected by using some mechanisms for this. But instead, I had to use many, many hours of both Git bisect and just trying to understand the code base, what is happening here. And it turns out, at some point, there was an indirect import via an import that imported the entire Sanity Studio bundle, which, again, was exposed to us. So it's highly avoidable, but it wasn't caught, it wasn't checked, because we're sitting on our computers locally. There are powerhouses of computers, and we can't see the effects. And the same is for things like accessibility. It's something that's often not top of mind. Some teams are better to check it than others. But again, we're sitting there on our top-of-the-line computers and doing verification of accessibility. It's hard, but we can also automate it. This wouldn't catch everything, of course, because accessibility starts often with a concept and the design of implementation. But this would cause and fix most likely the most banal ones that you shouldn't have there at all. So it's just a sanity check. It's quick win. Do it. In the front-end world, also, they have the tradition and philosophy of using Unix type of packages. That's the initial, the core idea from Ryan Dahl when making Node.js and Isaac Schultz when making NPM, that it should be like the Unix type of things. Many small components combined into a lot of different, more complex components. And this is also the reason why in the front-end world we're more susceptible and vulnerable to things like supply chain attacks, because there are a lot of different dependencies within dependencies that are vulnerable to just supply chain attacks. So we need some sort of mechanisms to control our security. This is, again, just an example using Snake, because that's what I know. There are a myriad of others mechanisms to use. But ultimately, DevOps is about ensuring that production works as expected, and it's sunshine. But to be able to do that, we have to observe it, and we have to be able to act on things that we observe as well. And we need to be able to mitigate that. We need to be able to verify. We need to be able to navigate code bases and make small changes to ensure that we fix it. But ultimately, again, I think it's more and more about the human level side of things. So DevOps culture is people and processes working together. And I think it's important that as front-end developers, we have to take ownership and build like the fundamental reactions of the entire team to do this. I think it's important to not only do DevX, but BoardX. And again, responsibility is key, and avoiding the blame game is key to that as well. Because it's consisting of production and operational responsibility, philosophy and culture, and methodology and processes. And we need to build a strong culture to achieve that. Well, it's easy to think that DevOps is YAML files, developer experience, tooling, CI/CD, infrastructure as code is so much more and more important than that. And it's too important not to take a part of and have top of mind and take responsibility of. Sure, just a few metrics to think about. Metrics can be misused in process, but I think these two from the DORA metrics is worth checking out. So to avoid deployment fear, try to measure your deployment frequency, because it's very hard to ensure that type of culture in your team, and it's easy to let deployment fear creep up. And cycle time for changes. And again, there are obviously ways to game this type of metrics, but the main point of it is having the discussions, having the conversations within the team, and trying to achieve it together. My point is that not only that DevOps for front-end engineers, but that DevOps is for front-end engineers, and it is for you. Thanks, that was all I had. Before you go, if you like what you hear, I have a Norwegian podcast that I've just released. It's been since 2018, but we just released it on podtoppen.no, and we're trying to beat the technology. So don't listen to it, but download it. That's the most important part. Thanks.